Good morning, sir, and good morning, everyone. I am Manoj Naran, currently holding my ID number as 251FB04003, currently pursuing my MTech in Computer Science and Engineering. Today, I am going to give a presentation on fractional knapsack problem. Introduction to knapsack problem. Suppose you are traveling by aeroplane. The airlines only allow a bag of only certain weight. Let us take the weight of the bag as 15 kgs and you have several items to be packed. Consider some of the items like clothes, laptops, and shoes. You cannot carry all items because of the weight, and each item is associated with a particular profit. You have to choose an items to get the more profit or maximum amount of profit without exceeding the weight of the bag. Constraints of the knapsack problem. The knapsack, a bag, is associated with predefined maximum capacity, and each item is associated with a specific weight and profit. And total weight of a selected item should not be exceed the capacity of the bag. And the main goal of knapsack problem is to achieve the maximum possible total profit from the selected items. Classification of knapsack problems. Knapsack problems are classified based on item selection constraints, whether you are selecting an entire item or a fraction amount of item can be selected. The main variants of knapsack problem are fractional knapsack and 0 by 1 knapsack. A fraction of item may be selected in fractional knapsack problem, and an optimal solution with maximum profit can be achieved in greedy approach. But in 0 by 1 knapsack, fraction amount of item cannot be selected, and whether you have to select a complete item, that may be 1, and you can reject an item, maybe 0. So the optimal solution cannot be achieved in greedy method, but you can achieve an optimal solution with maximum profit in dynamic programming approach. In this video, we are going to know about the fractional knapsack problem using greedy method. What are the feasible solutions and how can you achieve an optimal solution? Greedy strategies for fractional knapsack problem. We can apply different greedy method for fractional knapsack problem like greedy based on a profit, greedy based on weight, and greedy based on the ratio of profit to weight. We get different feasible solutions from three of these methods. Only one guarantees the optimal solution. Statement. Let us take three items A, B, C associated with the weights 5, 10, 15 and profits 30, 40, 45 respectively. And let us take the size of an knapsack as 20 kgs. Greedy strategy based on a profit. In this strategy, items are selected in descending order of the profit. Means we are greedy on profit of an item. The item with highest profit is chosen first, and if the item does not completely fit into the bag, a fraction item can be selected. Here, the items are arranged in descending order of the profits. The weight of the bag is 20. So we have the weight of the first item is 15. The first item can be fit in the bag and remaining weight is 5. The profit of first item is 45. From remaining weight, we have to insert the second item, but the second item weight is 10. So a fraction amount of item will be inserted, that is 5 parts of a 10. So the profit is 20. The total profit assigned by greedy profit is 65. The second strategy is greedy on weight. In greedy on weight, the items are selected in ascending order of the weights. The item with least weight is chosen first. If the item does not fit fully, a fraction amount of item can be fit. Here, the items are assigned in ascending order of their weights. Here, items are selected in ascending order of their weights. A have less weight with 5 kgs and C have more weight with 15 kgs. Here, we are selecting an item with less weight initially and we are going to an item with more weight after. Initially, the size of the bag is 20 and the first item weight is 5. We have selected the entire item with a profit of 30. Next, the remaining weight is 15. From a 15, we have inserted the second element with a weight of 10 and then remaining weight is 5. So, we have selected an entire item with a profit of a 40. And next, an entire item cannot be fed as the weight of a next item is 15. But the remaining weight is only 5. So, the 5 parts of 15 is selected. Therefore, the profit is 15. So, the total profit achieved from greedy by weight is 85. Greedy strategy based on profit to weight ratio. In this strategy, we have to first compute the ratio between profit to weight. After, items are arranged in descending order of their ratio. If required, a fraction of item can be selected. Here, the items are arranged in descending order of ratio. Here, the items are arranged in descending order of the weights. Item A have more ratio that is 6 and item C have less ratio that is 3. The weight of knapsack is 20. So, the first item can be inserted and remaining weight after inserting the first element is 15 and the profit of first item is 30. From the remaining weight, the second item is inserted that is 10. After inserting the second item, the weight of the bag is 5 and profit of second item is 40. But the third item cannot be fully inserted into a bag as the weight of the remaining weight is only 5. So 5 parts of 15 is inserted into the bag. So the profit obtained is 15. So the total profit obtained from this is 30 plus 40 plus 15 is 85. These are the three feasible solutions that we got from three greedy approaches. From greedy by profit, we got a total profit of 65. And from by greedy by weight, we got a total profit of 85. And by greedy by profit to ratio, we got a total profit of 85. So we have to select an optimal solution that is nothing but a process with maximum profit. Here we got a maximum profit from greedy by weight and greedy by ratio. Greedy by profit to weight ratio have given the maximum profit that is 85. Although greedy by weight also gave the same profit in this case, every time greedy by weight does not give an optimal solution, but greedy by ratio gives an optimal solution every time for all knapsack problems. Pseudocode for knapsack problem. Initially declare a variable that stores the capacity of the knapsack and two arrays value that indicates the profit of the each and every item and weight is the weight of each and every item. And the output we have to compute is maximum total profit of items that we are inserted in the knapsack. For each and every item, compute the ratio between the profit and weight. Sort them in descending order and declare a variable to store the weight every time after inserting an element into the knapsack and remaining capacity to update the weight every time after inserting an element. Initially take an element. Check whether the weight of element is less than the capacity of the knapsack. If it is less than the knapsack weight, then add profit to a variable and update the weight of the knapsack. If the item cannot be inserted, check whether the item can be inserted fractionally and insert the item fractionally. return the total profit. The complexity of knapsack problem. Initially, you have to compute the value to the weight ratio or profit to the weight ratio for each and every item. So it takes big O of n time complexity. And to sort the elements in descending order of the ratio, if we quick sort or merge sort, it takes big O of n log n and traverse the items and fill the knapsack. To do so, it takes big O of n. So, when combine all the time complexities and after removing the constants, we get big O of n log n as time complexity of a knapsack. Conclusion. The fractional knapsack problem allows fraction selection of items. Greedy strategies based on greedy on profit and greedy of weight does not always give the maximum total profit, but greedy on profit to weight ratio always gives the optimal solution. The greedy on profit to ratio always give local optimal selection that leads to globally optimal solution. Therefore, profit to weight ratio gives always the optimal result with more profit.